I've made it really quickly. I prepared the stream really quickly. I expect issues with Restream again. So let's check it, and if all works, and we'll just kind of seems to work on YouTube and also on Twitch. Yeah, okay. So now we'll just post message as usual. Okay. And yeah, seems to work. And I see Shumber typing, but that's probably unrelated to this stream. And yeah. Unless you are typing to me and you just mean that YouTube doesn't work. And you just no, but it does seem to work. So I don't know. I will just continue with my stuff, and what I think I will start with is adding string support in the Lexer. So I want to be able to print Temen like here. Okay. I'll ask him a question. Yeah, okay. So that's just super confusing. Not sure what to do about it. Basically, Polygo is also streaming just on the Discord server, and we use the same channel for stream chat with Restream for both my channel, his channel, and also the Discord stream. So that's what basically happens. But what I will do now is add support for strings. It will be of size. Do I pass an arena? Not really. Okay, so I think what I will do... Okay, so first of all, we should advance. Lexer advance. Okay, Lexer. And now while... I guess I will make the size 0. And while the string peak Lexer at 0 isn't this, and we are not EOF, so we are not at the end of the file. As long as this is true, we increase the size by 1. And I guess this is string data something. I know this is not a pointer, this is a thing. And this is string. I don't really like this being named string, but if I name this data, I would have to type dot data dot data, so I don't know. Yes, maybe at is what I do. Maybe that makes more sense. I don't really know. But yeah, okay. And now would be at Scratch Arena. Yeah, this is supposed to be a Scratch Arena. So I'm just doing some temporary work. And I don't think I want to talk about arenas, but that can wait. First, let's finish strings. So now, as long as we aren't on this character, we increase the size. And we advance once. Okay. And then if lexer at equals this, we advance once more. Advance, lexer. I guess this would be a string peak. Okay. Yeah, and I guess that would be it. Technically, I should also error if it isn't. So lexer error lexer missing matching string quote. Missing matching string end quote. I don't know. That's fine. And then now the arena thing. Problem with arenas right now. I'm not exactly sure how I want to resolve it. The problem with arenas is that we decommit memory when we unwind them. So when I have a scratch arena, I store like the state of the arena, like the position that we're at, and then we do some allocations and then we restore that position. And if we have committed additional memory, we would uncommit it. And that's good because it makes it so arena doesn't like basically like leak memory in terms of it like it happens to once allocate a lot of data and then it doesn't allocate that much anymore. And at that point we would be leaking memory using more than needed. But on the other hand, if we keep decommitting memory, it means we have to call virtual alloc and virtual free a lot, which are not free. They are pretty expensive as far as I'm aware. Although maybe reserving the address is what's costly, but I feel like committing physical memory is what's more costly than just reserving an address space. But I'm not sure exactly, so I'll have to research that, I think. And that's about it. Okay, and now the thing with strings is I think instead of making... So basically now result add equals... So what I will do is I will have a storage. So in lexer, I will add a storage arena. And if it's assigned, oh no, not here. It's here, arena, lexer, storage arena. Okay. And I think what I will do for now is I will keep this optional, or no, maybe not. But at least for this, I will. And this arena is for storing strings, basically, so they don't get deallocated after lexer, after we unload the file memory. Because we don't want to have to keep the entire file in memory if we don't have to. We only need some strings and we only need... I guess we need identifiers and strings, but we don't need the rest. So that's probably a good move. I I think. Although that might fragment the memory because we would be storing both tokens and you'll be storing both tokens and what is it? Expression statements, whatever. So they would be intertwined in memory because of the way we call into stuff if we share the same arena. So that might not be desirable. Maybe we just want to store the file permanently. Or rather, maybe we want to keep the file in memory as long as the AI script is as long as the lifetime of the AI script. That could be it, but I don't know. For now, I will just basically push string result on Lexer arena. Okay. And I think what I will also do is do the same thing for identifiers. Huh. No, actually, it makes no sense because if I ever want to... Wait. Actually, this makes no sense. I shouldn't be allocating the... So the copying I should only do for runtime values, I think. Because the tokenizer... it's called and then basically this... I don't remember the D word. Dissolve? No. Disposed. Oh, yeah. So it's disposed later. And then what we really need is to be able to store the strings on the runtime if we need to. So let's for now not have this arena. Here. Okay. And now in the parser, okay, and now in the parser, have a value string. Oh no, that's not in token. And the expression in runtime value, I would also want a string value. String. Okay, and now at this point we can just push this as push this string into the local into the parser's arena instead of the Lexer's arena, which is temporary. Resolve expression. Wait, this is the token up. Okay. Nice typo. Okay, and that means we have strings. And now I think what I want to do now is have other expressions. So we have all those. But now we would want all the logical ones. So I think the precedence is like or. Wait, or is supposed to have more precedence than and, yeah. So read logical or expression, which would be or, really, just or. And here we would accept the additive expression. No, wait, what? This is supposed to be here. So now we would read the additive expression. Then we would want a logical and. This is weird that I have to have two separate ones just for one type each. Fine, that's fine. And then we have logical equals. Or maybe a logical comparison. And here we would have all the less than. Less or equal to, greater than, greater or equal to. Another thing would be equals, not equals. Okay. Seems correct. And this would be calling for and this one would be calling logical or. And now comparison expression would be right here. And then there's another thing that which is unary expression. And it actually has to be here. Unary expression. And the statement here would be unary up. For now, let's just do. Well, we have negate. Yeah. So negate, and what we would do is we would read. Yeah, this is weird. So I will call this top, I guess, and then now this would be a unary up. I think this is how this would work. Okay. I think we should have all the other expressions handled now. And then what I need to do here is okay, and now result integer equals left integer right integer, and I will not have an explicit bool type. I don't think. I will just have I will just start as an integer value, like you can see. I don't really see a reason to load the type system with a type that is so primitive anyways. Like, it doesn't need to be like, really what I want bools to be is just like an expression, not essentially its own type. Because because I want you to be able to like say if whatever, like if left, then do something or whatever. So basically, Ben has way more. Hmm. I don't even know. It's just flexible, powerful, whatever. Because if I can have, it's just not. It's like more readable if you can just read if unit this instead of having to like check if unit isn't 0 because unit is not a bool, so you have to like make it a comparison or whatever it is. This is so bullshit. I don't want done. So this would be statement integer equals result integer break. Okay. Thinking up mostly does it for those. Okay, so let's try doing. Or maybe what I should do is have in primary, if I have lex token type identifier and identifier, f string compare token add and true. So I get string and compare token data token true, and this will be token add size like this. And then if that's true, then we just create an integer of value 1, and also otherwise else false. We say 0, and else we say for my parsing of this identifier, it's unsupported. Another thing I would want to do here how do I do this? So I want to print the entire line and then basically mark the word and flex token line token. And I would have for I0 I token column. This could be put C because that's way faster, and then std out. And I would put C this. something like this. And I suppose this would be -1. And now what I would do is line start equals token add minus. Oh, this would just be a char star pointer, and this would be token add minus the token column. So this would be the line star, and this get lex token line would be what I do, and then I would print f send as format string get lex token line token. Okay. So be string format. And then this can just go. Okay, like this. And now this would be token add minus token column. So this would be token add data. And now what I would do is while how would I do this? So basically need the lecture at this point. I'm not sure. I want to print the entire line, so basically while string peak, or maybe you do this for char c equals string peak. Fuck, man, I don't know, because for now I guess I will just print it until the token, because I don't really know how long the line is, and I also don't know if there isn't some garbage data there, so I can't just read it. I need to pass it somewhere, probably stored in the token or something. I don't think I print Lex token anywhere right now. But what I will do for now is I will just print it here. Result. So we can see every fucking token. That's not epic. Yeah, I see. So that should be fine. Yeah, that's perfectly what I wanted. So now it like shows you what character, where the token starts with the 0. You know, it's really useful. Although I'd really want to print the entire line instead of just until the token. So to do that, I think we'll have to I would have to get the line in the lecture. Or maybe what I do here is I don't even think this has to be 64 here. And then this would be line end. Or line size instead. And then okay, now every time I have reference line, I'll have to correct this to not be LU but just U. Okay. A single line, column. Or honestly, I will not really bother with that because so this is the time, this is the thing. And I guess line is all I need because column will be just nicely highlighted. Or maybe I leave it for now. Doesn't really matter. What does matter though is getting the token line end. The thing what I will do is here I'll calculate it. So now for EU lecture size. I think I'll do this here then. And then until the odd size e plus e, and then if string peak, or I know this is checked by the size, so you don't have to peak. That's more performant that way. And if the data at e is either so char c equals this. So c equals either error or c equals n. We break. And what I will do here is have lecture line size equals to 0, and this will plus it here. Okay. Incrementing this every loop maybe not the best, but then I don't have to handle the case where we overflow, like, or maybe that's fine. Oh, yeah, it's probably fine. So what I would do here is actually just do this. And that should do it. And now we know what the line is in the Lexer. We just have to now assign it when making a token. So line size. So now token is aware of the line size, which means we can just do token line size. Okay. Something's very broken. We still have 12, by the way, so that's fine. But we don't no longer print this correctly, which would mean that probably the line size is 0. And that probably means that the first line is not line checked. And I think that means okay. So So what I would do is lexer column equals 0. And we would do this, right? And we also would want this. Oh, I guess what I can do is increment this here anyways. Because we reset it anyways if it would be reset. Okay, so this should mean the first line is also checked for the line size. And this indeed seems to be correct, although there's one more mistake. This line size needs to be later incremented by additional 1. And that's because we check with less than instead of less than equal to. So size is basically plus 1, what the index would be. Indices are 0 based and sizes are 1 based, basically. You can think of that like that. And yeah, that looks really epic. Although the first one is still not red. And that tells me that we have not advanced here. Right, because we wouldn't advance at the beginning. So let's just do static void lexer measure line size, right? Lexer, and this would do it, right? And then when we update, we just post this here. And at the beginning, when we make the lexer, I think, is where we would do this. Like here. Okay. Think that will do it. Yeah, look at it. Look at that. Perfect. And I guess one another thing is that I can also, instead of just marking the beginning of the line, I can just use token data token add size and print as many hats as necessary to cover the whole token, right? Okay. And I think we'll have to make this printout more succinct, so it's takes less space. Okay. So we'll move one new line here, one new line here. And I think I will add a tabulator, because this can be putsy like this. And we would have printf n t, and then here it would be n. And now what this does, oh no, actually, no, I'm mistaken. So like this would work. No, actually like this, okay. So this should tabulate the whole thing. So now if I write, yeah, I'll be able to finally remove by the way from the evaluation code eval statement by the way. And that's because I will change this to be 30 333 plus 33 plus 3 is greater than just ordinary 3 times 3 plus 3. It's just something like this, maybe. And I just have to be very careful to not have 12, by the way, because then I wouldn't have a by the way, and it would be really bad. And we evaluate true, which would be correct. Although I see a problem here, because I see subtract. And this is an add. So this must mean that I either... This must mean an error in the lecture where I have a typo. So if you see here... Huh. Interesting. So let's see what this says. Yeah, you can see triple hat. Yeah, that's really weird. I will fix that in a sec. But. Relax token. I think I'll remove this new line here. I think I'll print this thing here like this. Okay. Okay, so I will actually leave this percent you here can mine this, and now this will be the padding, and then we'll add padding here. And we'll do it like this. Doesn't seem to work as intended, unfortunately. And now it seems to... So the tabulator car was the reason. I would also want a space here. Okay. Oh, doesn't printf do something stupid where... So instead of returning... No, it does return the length of character. I'm pretty sure it does. It should return the amount of characters that it printed. But I know that std... So scanf would return the amount of arguments that were successfully scanned. And printf returns the amount of characters that were printed out. Instead of the params that were successfully scanned. Yeah. And the return value on success, the total number of characters written is returned. Okay. So this means this is all correct. Epic. And now what this means, I can just remove this. And I guess that is fine. Okay. So now we should have very pleasant debugging with this. For error messages and also for just my workflow right now, where you can see that, oh, integer 333 equals to 333, so this is what it evaluated to. I see which line, so line is 0, which is actually kind of wrong because it should be line plus 1. Since we as humans count from 1, not from 0, but the parser is written in a this is just zero base because it's easier to work with zero base stuff and in the machine, whatever calcs. And yeah, if we look now, we have this perfect thing. Yeah, this is really fucking great, honestly. But now I have to just I have to check what's up with the operator. It's definitely not subtract or divide either. It's like it using divide, subtract, what the fuck? And the weird thing is that we do have... Oh, it does say that it's subtract. I know what this is. This is this dumb thing that I have not fixed. Do I have CSRD? CSRD. No, I didn't make it. I guess for now I will use static assert from C++, which is really stupid. So instead of declaring the type here, I will not, and instead I will check if the array size of lex token type names is equal to the count. And it currently isn't, which will fail. It's perfectly, it's exactly what we wanted. We added an enum, which shifted everything by 1, but we haven't added it here. So after decimal, we need to add string. Okay. And yeah, now it worked correctly. Okay. I will take a quick break, so I'll be right back. Yeah, static assert is complaining here. Because static assert is not... It's not a good fucking feature. It's made in C++. It expects me to like write something here as a message xd, And now if this would be wrong, it would give me XD. Which I suppose is fine, but... Okay, it doesn't... It allows me to compile, so that's fine. Okay, so it looks like we have incorrect priority, so I probably have assigned them incorrectly. Okay, I see. So basically, comparisons should be here. I know, should they though? They are the lowest priority, so they should be the ones called first. I don't know. I don't know. Why isn't this correct? Comparisons are supposed to have the lowest priority. Oh wait, are they? No, I'm wrong. Yeah. So actually, this should be calling this. This should be calling additive, and this should be what we call here. So and is the lowest priority. No, also wrong, because and is supposed to be higher priority. And then this is supposed to be called here, and comparisons are supposed to be called here. Okay. So I just haven't figured out the priority list correctly. And now it seems like we... Yeah, okay. Now it's perfectly correct. Okay. And I guess I will also improve the printout of the statement. So I will do... Okay, it's fine. And now I'm not gonna even do binup. And I will also do unary up, and it will just be expression unary up statement, yes. I guess I will just negate this part. Okay, so we don't do unary ops correctly. Unless I just don't. Unary statement, unary up statement. So unary up parsing. I don't actually know how it's done. Unary, read unary. Oh, read unary here was not actually being called. So now we still crash. But let's see. Primary parsing of this token is unsupported. Okay. So that tells me that I have not changed. No, this is negate. Now the question is, does the Lexer have an error? Negate is just single exclamation mark. Yeah, it is a negate. Primary parsing of this token is unsupported. Primary parsing of this token is unsupported. Primary parsing of this token is unsupported. Read primary. Yeah, it's because they precede. Okay, so I guess because normally, from what I understand, when we draw the tree, we do it like here, right? Like this would be and or whatever. This would be like 3, and then if we want to add something to it, we would add it here, right? Like this. So yeah, this is the part that gets added, right? So we build it bottom up, but I think unary has to go because we are reading them in opposite order, where we would first read the up. So I don't know if this is correct. So we would want them in reverse order if we have multiple. So if I would also have bitwise negate, right? Or arithmetic negate, right? Unary expression parsing climbing, whatever. I literally like almost never get good answers from Stack Overflow. It's terrible. And I know that a lot of people, programmers, will just think that it's the best thing that happened and they can just solve all their problems with Stack Overflow, but this website just has wrong information all the time. Just unqualified people will respond. So AST parser TypeScript. Now quickly open up the repo. Okay. So this guy made a repo that I was watching, and I think he did do front end parser. So I think he had UNOPs, additive, multiplicative. No, he doesn't have them here yet. Let's see the last fucking thing. Front end parser. He also had objects in the language, which are fucking gross. But maybe I will need some extract types anyways. We'll see. Would rather not though, if possible. Add, eat, expect, produce AST per statement. Oh, I think he just fucking divided his code on like 10,000 little pieces. Oh no, that's in evil. So where does he have this? Because he has UNOPs. Oh, he doesn't. Fuck. Unary expression. Language parser book. It was a book. Abstract syntax 3. This is not it. Recursive descent parser Java. Can't find the website. Anyways, I just try to figure out it myself. What I would try to do is initially have top as 0. And if we accept, we would replace so do this top. Then a new statement unary up top, right? And then child will be like red, read, primary, expression, lecture, arena. And if top exists, then top, expression, unary up statement equals the child. How fuck? This is weird because we are prepending stuff into the binary tree, but then we want to append something at the end. Would we even want to prepend at all? Well, we do want to return the highest most thing anyways, but maybe statement, top statement. This is stupid. no bottom. If not bottom, then bottom equals new statement. And now, if bottom, then bottom, I guess. If bottom, then statement, no, expression, unary up equals child, right? And we don't have, then we just say top is the child. So yeah, that should make it work, although whatever is higher is lower in precedence, so first one would be the lowest, and the last is... So, if we have like a double negate through or something, we want this one to be high, to be lower in precedence than this one. So we want this to go reverse in precedence. So that's why we add on top instead of at the bottom. I think this works, but I don't know if this is the quote-unquote correct way of how to do it. Or, like, I would prefer to not have to have this if, for example, or this if. It makes it a bit more slow. And yeah, we have now the plugs printed, and I think print depth will print an actual tabulator, so 4 spaces. 4 spaces is the right amount of spaces, remember? It's not 8, it's not 2, and it's not 3. Okay. So it negates less than... So this order here seems to be correct. This AST. I really like this formatting now. It's really good. I guess in debug mode, maybe I should also print the fucking, like, embed the original token or something. I don't know. So... Hmm. So I do want to name this left, right, and... So I basically want to parse this in name, so this is a bit more readable. It should do it. So yeah, now we see this as an actual. Oh, I guess if there isn't a name, we don't want to print it because otherwise we have this like floating column at the beginning. And yeah, this makes it look more like an actual readable thing. Although now we have some error with the expression. Oh yeah, of course. Okay. So now let's actually check if true and false work as because I have added them to the language. So let's see if this is equals true, I guess. Okay, I was muted. I don't know for how long, but yeah, we are starting to see this. I wanted to try with this. That's the true statement, right? And I really appreciate the printout now. It's really useful. Really makes it readable. And it seems that true evaluated to 0, which is wrong. So in parse primary, if the lex token type is an identifier, token true. Okay, let's see this case in debug mode. I guess I should actually. Oh, maybe. Oh! It's because this actually returns 0 if it's correct, so I have to do this. Okay, so now we should see. Yeah, okay, it works. So it checks if equals is 1. I don't know, this is pretty epic, I think. So now this could allow us to hard code some identifiers, some constants. And also, this can be used to have variables. I just need to make a concept of scopes. And environments, I guess, they usually call it. So let's define the first division is that I don't want this expression and statement thing. That should be pretty implicit. So let's just remove x here. And just replace this everywhere. Okay. And now what I will have is a struct that is called scope, and what it will be a list of statements. Okay. Okay. So now I think what I need to do to add that is a token. So lex token equals peak lexer peak token lexer. And if or maybe instead of doing that, I just do accept token lexer lex token type open brace, yes. And then I read this into the token. And then I would expect Lexer. So we make this statement. No. What is my helper? Push statement. Arena statement type scope. Okay, so this is a scope, and then we basically will list on scope scope statements. Okay, and then this is it. Okay, and if we accept a close brace, that means the end of scope, and otherwise we just read statements. And now one thing about read statement is when we read an expression, we would like we don't have semicolon handling at all. So I'm not exactly sure. How that works. Let's make sure that brace is what I think it is. Okay, yeah. I'll try doing this. Basically, we expect a semicolon at the end of this, and expected semicolon at the end of expression. This might be a trap because we. I don't know, never mind. Okay. And then this read statement. Okay, I think that's it. Read scope. And yeah, we return expression. So I guess if there is an expression, we would expect a semicolon. And if there isn't one, then we just return 0. Because eventually, when we go to primary, Because if we happen to get an EOF, we just resolve equals 0. Because we don't actually want to error out on end of file, right? I mean, unless there was something expected there, but... And I guess if we don't have a statement in this code, and we would want to break, but this is technically an error. I think. Okay, so now we should technically get an error where we don't have a semicolon. Expected semicolon at the end of the expression. Yes. We still got an expression though, that's fine. Okay. And now if I add a semicolon, that should be resolved. Okay. It does work. And now if I do... Let's have a print. We need a print. Otherwise, I can't really do scopes. So this will for now be very hard-coded because I don't have the concept of functions yet. So basically, as a read statement, I would have read read print are coded for now, replace with function later. Okay. And basically what this will do is Lexer accept token. And this is ugly because I need to make this token equals Lexer peak token Lexer if token is of type Lex token type identifier. So I basically will need a special fucking accept function for identifiers. So maybe I just do that identifier. And what it would do is const char name. And we would expect a token type identifier, and we would also expect a string compare of token data add data name and token add size, and we would equals 0. And this is not invalid, it should be identifier. Okay, so now this is more useful. So now instead we have Lexer accept identifier print. And then I would have Lexer expect token Lexer Lex token type open paren 1. Yeah, okay. Expected open paren next to print. And then also close paren. Close paren at the end of print. And now we would do Lexer, or rather read expression. And since I need to add it to the AST, I need to make I need a type of statement that is just print to do replace with native function call function later. Okay, and I'll have a struct print stmt expression, and I guess this should also be expression here. And scope is actually a statement. So let's actually separate them just by command, where they will say expressions. Statements. Also make it an expression probably, since functions have a return value. Can have a return value. Okay. And those are statements. Have scope first. Like this. And now XPR is just removed. Okay, so now print is a thing that reads the statements. That reads statements. And now what we need is basically we need an eval for statements. So for scopes, we just run each of it. So we do a statement stmt stmt equals statements scope statements first stmt equals stmt link next, and we just eval those statements statement. And result would be invalid, so that's exactly what I want. And then print, just eval the statement of, oh, so this is meant to be stmt. And this would just eval print expression. And for now, since we only really evaluate integer still, I will just print the integer as it is. Okay. Okay. And now what I want, of course, is what is the C++ thing? C++ multi-line string. Oh, no. Stupid as fuck. Okay. So it's error. Like this, I guess. Okay. So now what I would have here is a scope where I would print this thing. can't do 12 because I'd have to say by the way. Let's see if that all works. Okay, so this and this equals true. That should be correct, but one thing I did not yet do is expect a semicolon after the function call. Expected semicolon and the end of print. Semicolon. And now what I want to do is Lexer error and then print next token. Token. Right. We have an error, we want to print it. Right. Okay. Lexer error this one. Is this all the formatting? Where do I use this? Expect token and string. Okay. Okay. This is epic, I think. Parsing of this token is unsupported. Print free. What the fuck has happened here? Okay, so there are many issues now. So it seems like skip or white space doesn't correctly count the columns or something. I don't really know. So first of all, yeah, this is because fuck. It's because of tabulators. We don't do them correctly. So column for tabulator. This is stupid, but basically else if C0 is a tabulator, then we plus equal by 8. That should do it. Although not really, it's like, I guess it would be plus plus. Let's do this. So it would be Lexer column line about 2. Lexer column 8. And I guess I could just, yeah, that should do it, I think. Fuck, man. Yeah, that's wrong, though. I can't do that because column is referring to the character. So you have to like do column. This is so stupid. Just don't want tabulators. static void print flex token line. So instead I will just do this. And instead of doing this, I will just for token size plus plus e. I mean, I will do string equals token, and this is line, and this is semicolon, and this is line size. This is just a value type, and then I put c whatever is add that I do std out, and then I also just put c a new line. Oh. And now, if this is a tabulator, then instead, we'll just make it a space for our purposes. And we will skip it. And now this should be removed. Okay. Yeah, this does it. But I have an extra new line that I do not need. I don't really know where it is though. Oh. It's because there's a new line. That's weird. Okay. Primary parsing of this token is unsupported. Close brace. Line 6. Primary parsing of this token. Why would it expect it as a primary though? So also that's probably why we don't return the scope here. And then I guess same happens. I haven't actually finished, so let's name this print. And no, let's make a statement print equals push statement arena statement type print, right? And then we return the print and we make this print expression like this. Okay. Okay, so I hope this would work now. Okay, it seems to work. It's just evaluation has some wrong garbage data in the printf, I assume. So if we go to eval statement LLE. Oh yeah, of course. This would be integer. Yeah. We shouldn't assume integer here, but we haven't added full type support yet. Okay. Yeah. Oh, I would be so mad if I was muted for this entire time. Thankfully, I wasn't. Okay. So this would be it, I guess. But what I also wanted to do today is to say 0, which I think is correct. And then if I say equals equals false, it should print 1 instead. It does. Okay. That's really epic. I guess I can check if double negate doesn't break the program. Since that unary expressions is something that I have done myself, I think it does break it. Oh, we so 9 is, I guess, I don't know why I'm not just reading the structure of the program. So I'd rather not print it here, since it's a bit unreadable. Yeah, I guess maybe what I should do instead of replacing tabulators with spaces is just trim left. That's something I can do inexpensively on size-based strings, and it's more consistent anyways. So we would expect the line to always be printed the same way and not like randomly be more offset because it was deeper in the scopes. So I think that would make sense. I guess I can do statements if this is all working correctly. Okay. I have to think what I need. Okay, by the way, this doesn't need to do anything. And print statement. It's probably fine. Okay. Oh, you know why I'm getting this spam? It's because for testing before I've made this thing for where I would print every token, right? So I don't want that anymore. I only want to print them on error. And I want to see the AST. Okay, I know what's happening. I have not added scopes and prints to print. So it's like I would print f scope, right, scope like this. And I would then close it here. And here I would print the statement as yeah, I'll grab a Scratch Arena here. Scratch. And Scratch Arena. And we'll keep print f Scratch arena %u, and then it would be like E0 E. Yeah. I think that makes a lot of sense. And then and printf would just print I would just print statement, print expression maybe. Oh yeah, and I forgot to increment the depth here. Oh, this is really starting to become a language. It's really epic. Okay. So yeah, now we have a scope of multiple scopes. Oh. Yeah, this is not a scope, this is a print. So yeah, we have a scope of 3 prints. Oh, this is so epic. Okay. Starting to have a language. Let's add the if statement then. If I guess we have to make this stupid. So we would have condition, then and else. This also has to have an underscore. Okay, and now, no. I also should make like a list of. And I guess I will be jumping a lot now, but I have a few things I still want to do before I close the stream. And this would be board string trim left, string, and I guess it's actually string like this and string like this, string. Okay, trim left, trim right, and trim. Then I guess I would want string eat left, eat right, maybe. And I would probably want like remove prefix, remove suffix. Maybe I don't want to bother for now. Okay. So now, while string data, so while string size, now char c string peak, or I guess I don't have to because I know that string size is greater than 0, so string data 0, and fc I guess if this and string data 0 is any white space, we just string data ++ and string size -. And I think I will have char string last, string, string. So return string size, then we return string data string size -1, otherwise return 0. And here while string size and is any white space string last string. Okay, and then we just remove, so we just chop the size and stream, and we return string, and then here string equals string trim left string trim right, and I guess we can just return this then, and I guess we can first do this and then do that. And another thing I can do is string first, which would be just getting the first character. Okay, and now line, basically string trim left line, and then what I need to do is we get Lex token size. Okay. Instead of this, I want to print f s, and it would be format string format token or line. I guess padding plus equals token column minus trim line equals trim left line string trim left. Okay, trim line. So now we want the difference. So minus line size minus trimmed line size. Okay, and then we just did this. Should do it. I'm not printing any Lex tokens as of right now, so I'll re-add this Lexer. Print for this result. Yeah. Print Lex token. Okay. Oh yeah. So I was still printing line instead of trimmed line. So let's see if I'm good at math. I guess I'm good enough. Okay. Seems to work correctly. Okay, that's really epic. think I can just remove this printout now. And let's finish this up with adding if statements. I know I'm up for 2 hours already, so it's past what I normally streamed for yesterday and before yesterday, but that's fine. There is a bit of a flow state going on, so why stop there? So now true, false, okay, that's fine. And where I need to add this is here. Really, by the way, this should be here, but it's not compilable. Anyways, outside of style stuff, the if statement, where do I add it? I added, should add it here. Read if. So yeah, static STMT read scope is what I want. And I will show why in a sec. Arena. Okay. Scope return scope. And what I could technically do is instead. Fuck man, I don't want that. Because we could just technically make it so. We could make it so you can have any statement after if. So you could say like if 3 times 3 print xd else something. But I don't really want that. I can allow this though. I think that would be fine. And then have either if 3 times 3 equals xd, or I guess print 3. Something like this. Else print 3 times 3 or something. And of course, and this could be an expression then. Yeah, I think I will do that. So remove this, and now if, and then I expect a condition. So let's prepare an if. If equals push. Push statement. Arena STMT type if, right? And then if holy fuck, why is this so stupid? Okay, so this would be a read expression, right? Flexor arena. And now we can either accept identifier token this. We can now either accept an identifier then or a scope. So if we have a scope, read scope, next arena, STMT, so if scope, then if dot then equals the scope, else we would do if Then, oh yeah, if instead we Elixir accept identifier Elixir then, and we do 0 because we don't care, and we can also not care about the token here. I think we do care here. No, we don't. Okay, so that's fine. And then in this case, we would just read an expression. Elixir. Lena. I guess. Well, it depends if I want to make this inline if an expression or not. Maybe I always make them expressions. And then scopes would only evaluate if there's a return. I don't know. Okay. Let's not have the expression kind yet. I guess. Let's just have those instead, right? If okay, this would be a Elixir error. How do I do those? Elixir. No, Elixir error is what I do, right? Let's do extra error then. I think it's static now, though. Yeah. Let's move it here. So Elixir, expected scout after if. And then if accept Elixir accept identifier Elixir else 0. Okay. That is fine. And then now if we expected a scout, I guess what we could do is static stmt expect scope AI Elixir arena. I don't know. I want custom errors, so maybe that doesn't make that much sense. If there isn't anything, there isn't a condition, and there isn't an else. Just do a lexer error lexer expected scope after else after if expected condition after if. Okay. So this is what reading if is, and now of course we have to then return if. Unless there are errors, I should just terminate, but for now I don't, which might be a really bad error. But I don't know how I'll handle that flow yet, especially that this is just a test. So far. Pum pum pum. Yeah, I lost my focus a bit now, but I was doing if. So I have ifs. I'm not bothering with the expression kind. So now let's do if. Then I just always print this anyways. Okay, so now I'll just print the statements. Condition, then else, right? Then we do statement if condition then else. And I guess to just not have to bother with explicit checking there, I will just return here else. Okay. And then when we evaluate an if, we should eval runtime value eval eval statement. Oh, another thing that I have not really done yet is does that matter? Because I don't know if I have short circuiting right now for logical stuff. I don't know if that implicitly happens because of how C handles it and I'm handling C stuff, but we'll check in a sec. So this would be if condition. Now if eval integer. So eval type runtime type integer, and we have an integer. We will eval then and else. We will eval else. And we'll do the same thing here. If there isn't a statement, just return result. I'm not sure if I should be doing that, but that's fine. Read statement not found. Oh. That is correct. Okay, I was incorrect with this. So I thought I was printing the name of the statement, but obviously that's not what I'm doing. It's printing the binary or unary, and then I'm printing and if scope. Okay. Well, I didn't really like that system anyway, so good, it's gone. Was not very, it was a bit messy, I think. So this does names, this does values. Okay. Okay. And now let's see. Oh, okay, so all I need to do now is if true, print 1 to 3, and otherwise we print 3 like this. It just fucking works. It just fucking works. So we have basic control flow already. That works. Holy fuck. And now what I need to know is if we are shortcutting or whatever the term was. So basically what should happen is if we have like see like 5 unit something or create unit something, then if this returns true, this should not get checked basically, because we already know that this is true, and this is used by programmers too to write logical stuff. Doesn't make sense to evaluate them both if there is no need. I mean, maybe you would want side effects. I hope that's not. Yeah, that wasn't audible. Anyways, maybe you would want to have side effects of buff, but no, I don't think so. It's not necessary, and it's also unexpected, really. It's not something that programmers are used to. And I don't actually know. Okay, so. Oh! Oh, I have not handled something. I don't have and or here. Okay. So and or. And yeah, we do not have shortcutting because we have not made those. And I need and is and or is or. But now the thing is, if we are short circuiting, then we don't want to ever right if left is ready. So those are very special. Who we I wonder how to do this structurally. Because for most of those, I want left and right to be evaluated anyways. But for this, I only want to evaluate left first. Check if it's true for or false for and. And then if it isn't, we would evaluate right. I think this will be a 3-hour stream, honestly. I will just take a quick break now, so BRB. Okay, so first I will do promotion because I think that makes more sense. And what I will do is static runtime value promotion maybe it's like eval promotion runtime value promotion. Okay, and now what this will take is left and right, and maybe what I do, maybe I just did this. Now I'll take left and right. And for now, I will just promote. So if there's integer and decimal, is so if left, if there's integer and decimal, I will promote them both to decimal, and that's what I will do. Okay, left, right type. So if this is runtime type integer, and this one is runtime type decimal. Runtime value per is pair of types. Runtime value type A and runtime value type B. Okay. So now if basically this, if one is B and other, I guess I will just pass it as pointers. And now the return is just this. I technically wouldn't have to have this bar in here, but whatever. So we check if either is done, and now we would do left, right, integer, decimal, and now that will mean that so we should actually just return from to, so let's say runtime value should promote, or maybe can promote, maybe could promote, okay. And now this would be from to return left. Otherwise we do 2 from right, return 0, and here we would do runtime value to promote equals this. We do this, and now if to promote, I guess it's to promote decimal equals to promote integer like this, and to promote type equals to runtime value type decimal. Maybe now what I also do is runtime value promote. Oh, I can't do that because this has to be manual. This part of code has to be manual. Okay, fine. That should do it. And now what I can do is have decimals, decimal here. So let's just grab this, and this is selection integer decimal. Okay. This I can technically just fmod, right? Pretty sure this is modular, right? Fmod clib c standard lib. I didn't like this. Yeah, it's a reminder of the floating division. Okay. So that's fine. And now short circuiting is what I have to fix. I guess what I should fix is do it like this. Now I add this full string equals string a string here. Really had some string equals here, but oh yeah, there's string equal. I'll move those up since those are non-destructive, and now string equals this is funny because this is actually just result integer, I guess. Okay. This should do it. A parser. And yeah. Thank for this. This is so annoying because oh, maybe I also just switch on the left type here, and then this is a case. Okay, so this looks better now. So now basically what I would do here is lazy eval equals left type equals this, or right type equals this. No. Wait. This is for and then this would mean either this early eval. So now if left integer, then we do this, and otherwise. Yeah, this is kind of stupid because we would want to know what the type of the binup is, but we don't know. I think I would want to embed the type information in the binary tree itself. Okay, let's just not do that and do something else. So by default, so in this switch, we always will evaluate double. Like this will never do lazy evaluation, but this will. So now if lazy, oh sorry, if lazy. Yeah, so now. Runtime volume check. I think the. Oh, what's up, Milestone? I think the idea of embedding the runtime value types in the binary operation expression would be preferable overall, but for now I'm not doing that. I will just first do lazy evaluation, and yeah, that's it. But I feel like that would be better because right now we are just doing. Oh, this is not indented correctly. Okay. And here, what I would do, break. So result integer equals left integer. So with AND is if it's not if the left segment is not true, we know we can short circuit. So I will set evaluated to true and the type to the left type. And because it's really weird that I would only do promotion. Oh, also I can just do this here, right? Instead. So since this is a switch statement, I can just say if evaluated, then break. Okay. And we would do right. and runtime promotion. And then here, I have to finish this. And maybe I can just do this here. And I can remove IC eval, and I can result type, left type, or those here. Now I'll just do it here then, I think. And the ORs, on the other hand, they will short circuit if the value is true. So we do this. And now the same thing I can do for decimals. Here. Wait. Yeah, okay, and this would instead use decimal 0. Wouldn't I always want to return an integer if it's an AND? I would, I think. Okay, and then now I want to type integer for both. For all of those. Okay, so if integer, then this, and so I think that should make this effectively short circuit. I can't really test short circuiting because I don't have function calls really yet. I don't have expressions like that, but I could make print just return true, right? Yeah, that would make sense for testing. So print. This is eval statement. Print. And I would return a runtime value. Temporary for testing. Result type. Runtime value. Integer. I probably should make like a function, like make runtime integer or something, because typing the type assign each time is a bit stupid. And I will just make this return true. Temporary for testing. So let's actually showcase what I've done. Okay, so let's say if print 1, 2, 3 and print 3, 4, 5, right? 4, 5, 6, right? Print true maybe. Oh, I can't print true yet, but I guess maybe I add time support to print before the end of the stream. But it looks like this did not evaluate. I think that is because prints are not expressions, right? So in the parser, they wouldn't be added. So let's make them expressions for now. I am an expression. How did you know? And I guess I will just move them to expressions. Replace with native function call later. So that makes sense for them to be expressions because function calls are expressions. So I will briefly explain the difference between statements and expressions because nobody probably knows in the chat. Expression is basically like a string of concepts or whatever in the language that actually can be evaluated to a value like an integer or float or whatever. And statement is just like something that doesn't have value. So like if statement is a statement because yeah, even in the name, it doesn't actually have a value. Although if you're Rust, then it does. I think in Rust everything is an expression. Because in Rust you can do like something silly like let u equals u equals if free, like if free then free else 4 or something. Like this is possible in Rust, which is silly. But yeah, that is the difference. Everything broke. Print. So I'm not parsing this correctly somehow. Oh, it's because I'm actually supposed to do. That's the string equals token stringlet like this token out. True, and this is print. Okay. And then anytime I did make an stren comparison, I would want to replace this with string equals token add and string literal. Oh, we do not. I have not. I did not place semicolon in this code. Oh, I did. Print one semicolon. What the fuck? Print 4 5. So there's if condition. So it seems like the scope of the if did not work. We. Or is it wrong? I don't actually know. Let's read this. Expected semicolon at the end of print. Oh, I see. So that shouldn't need to be here because we already expect semicolon at the end of every like loan expression or whatever. I wish the game didn't have to run for me to test. Now it seems correct. So if the condition and between 1, 2, 3 of print 1, 2, 3, 4, 5, 6, then scope 1. So now this means that since both evaluate to true, then we get both printed and we also get printed the value. So this is true, so this gets evaluated and it prints. And then it still has to check the second one because it's AND. We don't short circuit. This gets printed correctly. And then print 1 happens because this evaluates to true. But now if the first one is false, then we should only see print 1 to 3 if short circuiting works correctly. Because this one would, this one gets evaluated and then the second one gets short circuit, which is the desired behavior, and then the third one is never called because we have return false in here. Okay, so we have a basic fucking language now. We can print stuff, we can do ifs and else's. Pretty fucking cool. No. I think I had one other thing I wanted to do. Oh yeah, so I want... So first of all, I want print to accept comma. So I want print to allow multiple arguments. So when I have print, I will have if Lexer accept token. So if there is a comma, the Lexer token type comma, then we would want to read. So this will become a list of expressions. Yeah, the linked list macros are lifesavers here. I'm really glad I have expressions. Expression. I'm really glad I have decided to use those. Okay, now let's compile so I can see all the errors correctly. Expression. OP, dot OP is also something that expression. Oh, it's something else actually. Expression. Okay. So now for statements, stmt equals statement print. I'm not the most proud of using all the shortcuts, abbreviations, but it's better than having like doing underscores or something. I don't want to do that. And then also, I have the type be short, so it's not lengthy, but I probably shouldn't. Yeah, I'll actually statement. I'll actually rename that statement. Okay. But oh yeah. STMT type statement type. STMT type statement type. Okay. Runtime value equals eval statement stmt. And now I think I will just have static void print runtime value. Runtime value. Question is, should I do it by? Yes, sure. Doing by pointer is probably fine. And now I guess I would print runtime value and printf a new line here. So if there is a link next, I would printf, I think. So in the case of runtime value string, break, this will be string format. Yeah, it's always done in a store. Okay. And yeah, I don't want to print a new line here actually because doing custom formatting. Okay, so now what this should allow me to do is to do print just print hello world. We oh, also this should be while, by the way. How do I make this happen? So this would be stmt expression equals this. It's as if it's not reading. Maybe string parsing is broken. Okay, string parsing is broken. So, lecture. To advance by one, we make a token. And until it's not enough file, and the current character is not a quote, we make the token bigger by one. We advance the lecture. There's some fucking problem here. So lecture odd, what is this? Lecture odd data. Okay. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So yeah, let's say lecture at data, comma, lecture at size 12. I know, sorry, this is this. Yeah, so this is perfect. So this is type value, and the value is the string, right? I don't know why I get Malwarebytes ads on stream. That's not fair. They haven't paid me. So push string. Well, this does seem to be correct because yeah, this is still So top top data, no, top value string. It is a hello world. Oh, see. Oh no, never mind. I thought Visual Studio is smart. It's just that I actually, when I push it, I just automatically add a null term. So that's why it's seemingly good. Okay, so now we go here, here. So yeah, we have this expression, which is just the value of type string. So that seems correct. And now we expect a close pattern. What is Lexer current then? What the fuck? This seems so wrong. Okay, so we don't care. It's already past 3 hours. But yeah, this is epic, Beaver. We almost have a language for AI, and it's really epic. So it's still peaked, I guess, right? No, it's not. Wait, the current is the string, and then... Oh. Oh no. I see. It's because eating tokens always advances by the size of the token. But the size of the token does not include the quotes in strings. So we were advancing by 2 characters too little, which made it think that there's another string starting, and it just broke the entire thing. So the way to fix it, I think, will be to, instead of peaked, would have current token size. And current token size equals result add size, like this. And if there is current token size, then return current, and then at the beginning, I guess since this would return yearly, at this point we would know it's always 0. So now here, when I advance, I also do some weird stuff here because I'm not supposed to advance like this in peak. But maybe I always want to. That would make sense. Bool cached. Cached token. Token, I guess token is cached, maybe? And I mean, instead of advancing here, we just advance here. Hmm. So if token is cached, then we return current, and otherwise we would lecture advance by token. Result odd size would be the default for most cases, but then maybe okay, so basically I have a helper function that will advance for me when I need to. Sometimes I don't want to advance, like here I don't. Here I don't. Yeah, this can go away. And now those need to be rewritten a bit. Yeah, this one will just work. And then this one, do an advance, and then while this is an EOF, and either is alnum. So we would do this, but inverse. So or and equals. And it would be. I didn't really like that. Let's do this. And we would do Lexer advance here. Okay, I think that works. Well, identifiers are broken. Yeah, I don't know if I guess it doesn't matter. It's probably fine to just have this result. And by the way, another thing. It's technically integers and decimals could start negative, but I think the negate operator will already handle this. And I wouldn't really want... Oh, we don't have a negate operator, I guess. I know, I'll have to think about it. It printed 12, by the way, I don't know why. We... So yeah, this should be grow token and advanced lecture result. Oh, did I just accidentally? No. Fine, I don't know. Uh... Oh, I just realized that Beaver was probably still talking to Pronago. But I still think it is epic. Was he? I don't know. But I know that it is definitely epic. Having our own language. Okay, so just let print every token I make. Token. Result. Oh, there's something really wrong. I don't know. I mean, another thing is probably I should. Oh, I don't know. Now this whole thing doesn't make any sense. I don't know why we're so broken now. So identifier is correct, then print is correct. And then it says there's like 3 different things on line 3. What the fuck? Like, why would we ever be here? I think I will. You factor this anyways. I will make this the mixer beat token mixer. And then I will make it so this is actually each token. And this would be peak token. Now here we would return mixer current. This cached I can remove. Okay, this is way better now. Organizationally, I don't need honorable. Result data. No, it's like lecture on the data. What was C0 here? It's a null char. So it seems like lecture and a file is wrong. That's interesting. Oh. I obviously should just advance here by the size. Extra advance. Because I was advancing by shifting the data, but the data pointer, but not decrementing the size nor computing any of the advanced stuff. So I guess that is very true. And it's still printing 12 by the way. This printout is really great though. I'm really grateful I made it. Shows you the line, it marks which fucking characters the token is from. Yeah, it's really neat. And all I will do now, because I have to walk my dog, is I will finish the Hello World. And this is a string. So maybe what I'm doing wrong is I'm not runtime value. So when I'm making a runtime value of string, do I assign the type correctly? Okay, I do. And then, so let's actually just print the runtime value. Let's breakpoint here. Let's see what happens. Okay, that's very interesting. It means that the value type is actually not string somehow. Okay, doesn't seem like we even print. Oh, yes. When we eval a value, we always eval it as integer. So instead, what we need to do, we have to check what the statement value type is. So actually, all we need to do is assign result as statement value. It's funny that in integer representation, the hello word was always 12, by the way. It still is 12, by the way. I don't think we compiled. No, still 12, by the way. I don't know. Well, it seems like print is actually never evaluated. I don't know what that 12, by the way, is then. So weird. That's funny. So it seems like it's inverted where the print where the print is like inside of the string or something. Oh. Yeah, it shows me hello world, but that's because it's showing the... What I should do is print statement. This is some lengthy debug session, unfortunately. I wanted to wrap this up at the hello world, but it's already taking me 34 minutes past what I planned to stream for, but that's okay. Yeah, so this is the print representation. So it seems like the print expression is not returned correctly. Oh, also this is incorrect. Hmm. So is it that the string, like, is it that the print statement is somehow ignored? Yeah, it seems like so. Oh, maybe. Maybe. Wait, let me. So there is identifier print. Let's read this step by step. Because it seems like the print is not turned into an expression, and then the next thing that is a valid expression would be the string. Oh, I know what it is. It's Lexer being broken again. So let's say if we have no size. Fuck. I guess I need to come back to the previous way of caching. So now. No, but I can't do that. It makes no fucking sense. Hmm. Oh, I know. All I need to do. So I have to, instead of returning the next token here. So yeah, I just still want to eat a token here. Lexer, eat token. Lexer. And then here I would store the current Lexer, current I would, instead of returning the next one, result would be next. Let's rename this to next. Okay, I think this is gonna be it. As I was skipping the first token, so I was always on eating token, I would always return the next token instead of the current token. I restructured some code, so picking. So we actually always advance the lexer towards the end of the current token. Since that seems to be more less code to execute. And less additional checks. But what I forgot to preserve is that each token actually returns the current token and not the next token. Okay, as you can see, expected semicolon at the end of expression. As you can see, nothing works again. But at least we have, at least the AST is correct. It's just that we are still reading some invalid thing at the end. I don't know why. And we are also not correctly printing the thing yet. But the abstract syntax tree looks to be correct now. Oh. It does actually evaluate. It's just... probably shouldn't do this here. Because if I do it in debug mode, then I would print it with the code. So everything works actually. It's just I didn't know it did. Okay, so in print statement I would make this debug mode, and in actual print I would make it not debug mode. And one last thing is fixing that expected semicolon error. Expected semicolon at the end of expression. Expected semicolon at the end of expression. It's really weird because we shouldn't really ever read. Oh, interesting. So this is the print expression, and then if I go here, I'm in release again, fuck me. I keep switching to release because it's like 1000 times faster, but then I don't get the debug info that I need. Okay, so the type is EOF, which means we have already skipped something. Let's see. Oh, looks like Casey has posted a new episode of Computer Enhanced, and the title seems interesting. So we'll be reading that later. I just need to fix this one last issue so I can finally finish the stream. but the progress today is even bigger than yesterday, and I thought yesterday was amazing. So okay, so we read an expression. Exert current is a close parent. Okay. Okay, now we do all the expression parsing stuff. I see. So the problem is now that the same kind of problem happens with N-upline where because we changed the implicit structure of this, how it's called. Now, if I previously I would be able to just make a token when we reached end of file, I would just return it. But now I have to cache it as the next token basically. So what I would do here is I guess I would do this where I would do it like this, and I can remove the Lex tokenizer. I mean, I can remove the print. Okay, and let's run. Yeah, as you can see, we have a functioning hello world, and it doesn't print an error. Pretty fucking epic. Okay, that's it for today. Long stream, lots of progress, pretty epic. So yeah, I'll try to keep the pace with streams and do one tomorrow. I don't know what I will do. I guess I will probably clean up the type system. I will do probably variables, maybe. I mean, I definitely need like local storage or whatever for scopes. I mean, do I really need it? I mean, at least I need globals, right? Because I need globals for defining the variables that the player needs to be like the user would be using for like reading the error advantage or whatever. So that's definitely needed. But I think having variables doesn't hurt. I know you, Pronago, use them a lot for your AI script stuff. So, dude, when you're actually gonna write in this, I think you'll be so happy because a lot of the fucking annoying AI script stuff you'll be able to just do very easily. And I guess it's really good that I decided to make the system like I did because now you'll be able to actually like contribute to AI stuff, right? And I think that will accelerate the piece of development a lot. Because you will just yell at me when something is missing, and I will know what to do. So yeah, bye. That's it for today. So I'll see ya tomorrow or whatever. Bye.